Hello everyone. Today we're going to talk more in depth about density. A quick review of what matter is. Matter is anything that has mass and takes up space. So it is anything that has both mass and volume. Things that are matter include a chair, a pen, a person, a piece of paper, your phone, water, ethyl alcohol, and also the air that you breathe. Things that are not matter are generally various forms of energy. For example, heat and light, which are both forms of energy, are not kinds of matter. They do not have a mass and do not occupy a space. Mass and volume, as shown in the lab that we did last week, have a direct or linear relationship. As one of them gets larger, so does the other one. And as you'll notice in this graph of some example data for mass and volume taken from the lab, this growth also appears to be very consistent. It is specifically linear as opposed to exponential or one of the other relationships that would have one thing getting bigger while the other one does, which implies that there is a set ratio between mass and volume, which would be connected to the slope of this line. Density is the measure of the amount of matter present in a given volume. An alternative definition for it would be to say that it is the amount of mass per volume. Therefore, density is this hinted at ratio. The slope of the line of mass versus volume that we took in the lab the other day is related to the density. Density has many different units that would be considered appropriate. Basically, as long as the unit is a mass unit divided by a volume unit, it is an appropriate unit. So for example, grams per milliliter would be a good unit for density and is going to be one of our most common. But you could also say kilograms per liter or grams per quart. These still have the same components, but they are a little less common because those are slightly less common measurements to record for the two other measurements. Density is an example of what we call an intensive or characteristic property. These are properties that will be true for a given material regardless of how much of the material is present. You could have 10 milliliters or you could have 1,000. This property will still be true. These properties are also usually unique to a material or are only shared by a handful of other materials, and then you could possibly, if you were trying to identify it, find another characteristic property to also compare. So for example, the density of liquid water is 1.00 grams per milliliter, and the density of aluminum is 2.70 grams per centimeter cubed. They have their own unique densities that you can look up. This is in contrast to what we call extensive properties, which are any properties that depend or vary with the amount of the material that is present. Most extensive properties are actually just measurements like mass or volume. So we can talk about density in two different ways, qualitatively and quantitatively. For a qualitative discussion, I want you to consider the question, why does oil float on water? In terms of density, assuming there's not something unusual going on with surface area of the object, when the density of one object is less than the density of another, it will float on that object. For example, wood is less dense than water, and so wood will float on water. When the density of one object is greater than the density of the other, however, it will sink. For example, rocks are more dense than water, and so rocks sink in water. The one thing I have not mentioned here is what if their densities are basically identical, as is the case for people and water, since people are mostly water. Generally what that means is they'll float either right at or just below the surface. So because they have the similar densities. So why does oil float on water? The answer is that oil has a density that is less than that of water, and so oil floats on water. Whereas another fluid, like mercury, which is more dense than water, would sink to the bottom of a glass of water. We can also discuss density quantitatively. Density is a measure of the amount of mass per volume. So before I reveal the formula, consider what math operation is implied by the word per. The formula for density is density, represented by a capital D, equals mass divided by volume. Mass represented by a lowercase m and volume represented by a capital V. Per implies division, so we'll be taking the mass and dividing it by the volume to find density. This is an algebraic formula, and as such, as long as you have any two of these three variables, you can always solve for the third one. So if you had, for example, the mass and the density, you could solve for volume. So let's take a look at an example calculation to see how this formula works. How much mass does a 125 centimeter cubed block of aluminum contain? And a reminder, as we mentioned on an earlier slide, that the density of aluminum is 2.70 grams per centimeter cubed. We have been given our density formula. Density equals mass divided by volume. However, we're trying to solve for mass, and so it would be convenient to algebraically rearrange this formula into a new form by isolating mass on one side of the equation and the other two variables that we know the values of on the other side. In order to isolate mass alone, you would multiply both sides by volume, and so the new form of this formula would be mass equals density times volume. You do not have to do this prior to plugging numbers in, but it is usually more convenient to do these math operations with the letters rather than the numbers and their units. So now that we have our formula and we've also transformed it, we should plug in the values that we know. Mass is equal to density times volume. So mass is equal to 2.70 grams per centimeter cubed, the density of aluminum, times 125 centimeters cubed, the volume of this particular block of aluminum. Now that we have plugged things in, we calculate and make sure that we are rounding to an appropriate number of significant figures. 2.70 times 125, when rounded appropriately, equals 338. So the mass of this block of aluminum is 338 grams. Let's take a look at a second example. A cube-like object has side lengths of 8.25 centimeters. Its mass is 950 grams. Is this cube made of aluminum? We mentioned earlier that density is a characteristic property. So if we calculate density, then we should be able to determine if this object is made of aluminum. Density is equal to mass divided by volume. We are trying to solve for density, so we do not need to rearrange this formula. However, we currently have side lengths and need to somehow get that to volume. For a cube, the volume is equal to the side lengths cubed, or raised to the third power. So 8.25 centimeters times 8.25 centimeters times 8.25 centimeters would be the volume of this cube. Rounding to appropriate significant figures, the volume of this cube would therefore be 562 centimeters cubed. We now have the volume, and we already had the mass previously, so now we may plug into our density formula. Density is equal to mass divided by volume. So density is equal to 950 grams, our given mass, divided by 562 centimeters cubed, the volume that we just solved for. Performing the division and then rounding to appropriate significant figures, we get the density of this cube is 1.69 grams per centimeter cubed. Alternatively, you could have plugged in the side cubed formula for the volume and done all your calculations in one step, as shown here. You could have done 950 grams divided by 8.25 centimeters with that denominator cubed, and still gotten the exact same answer. Either way would have been correct. However, we still have not answered the question. Is this cube made of aluminum? The density that we calculated was 1.69 grams per centimeter cubed. As mentioned on previous slides, the density of aluminum is 2.70 grams per centimeter cubed. Since 2.70 does not equal 1.69, this cube could not be made of aluminum. It must be made of some other metal. If I wished to know the identity of it, I would have to look up densities of various metals until I found one that matched.